So we're starting to see that where the area of our function is important when we actually are in trying to find the area of a function. If it's a definite integral, yeah, not a problem. We don't really care. But if it's an area, then we've got to be really care whether our curves are above or below the x-axis. So that's why it's important to sketch a curve. Okay, sketch the curve. It doesn't have to be a great sketch, but you should be able to see where the curve's above and below the x-axis. So it's really important a lot of times to see where it cuts the x-axis, because if you can find where it cuts the x-axis, that's where you're going to be able to split up your integrals. So if I wanted to find the area between of the curve for the x-axis between the x-axis and the points A and B, well, I'm dealing with the area up here and this area here. Now, if I just went and did that, I'd have a problem because I had to have all positive values here, but then I've had negative values to add to it. So I'd actually have something to be less than the exact area from A to C. It's because that would start to be subtracted away from that. So what we need to do is have to split it up, and this is where it's important to see where it's above and below, because we'd split up this function for an area to go from A to C of the function, and then from C to B, and take the absolute value of this part because it's negative. So that's why we have that part in absolute value, because anything below the x-axis we need to take an absolute value of there. So and a lot of times in the problems, the first point of the problem is to find the value of this value c. Where does it cross the x-axis? So we know where we're going to have our limits of integration. That's often worked in together, so a little bit of algebra to do to start off with. So if we have a look at some of the problems, the first one here, we're going to find the graph, the area enclosed by the graph and the x-axis here. So we're looking at the area in this part and this part. So if we're doing that, well, we can see that we've got to go from 0 to 4. Because 0 to 4, that's where the curve's enclosed. But if we just did that application there, we'd be in problem. We'd have problems because we've got a positive area here, but we've got a negative area here. So we'd be getting probably a negative answer because that area is bigger than that. So what we need to do is split it up and say, well, where does it cross the x-axis? So we know when y is equal to 0, okay, we're going to get the function here being equal to 0. So we can see that x would be equal to 0, 2, and 4. So that must be the values of x, which makes it equal to 0. So we must be crossing at 2. So that's why we're going from 0 to 4 with 2 as the point in the middle, and that's where we're going to split it up. From 0 to 2, we're going to get a positive area under the curve. But between 2 and 4, we're going to get a negative. So we take our absolute value. We split it up, we take our absolute value. Now, a little bit more work because we're basically having to write it out twice. So, same integration though, so that's the easiest. That's a little bit easier. So we integrate x cubed gives us x to the power of 4 over 4. 6x squared becomes 2x cubed, and 8x becomes 4x squared. And we substitute 0 and 2 in. So there's the 2 being substituted in. 0 substituted in gives us 0, which is nice. And we substitute 2 in there, and then sorry, it should be the other way around. Let's substitute 4 in and 2 in. And it's been done correctly there. So that should be, and so we've got the 4 and the 2, and then we get our values as we're putting in there. That works out to be minus 8, because these all cancel each other out. When these is minus 8, we take the absolute value, gives us a positive 8. So the area in this part is 4. The area in this part is 8. And because it's below the x-axis, we get a negative. We take the absolute value because we just want the area, and that gives us a total area of 12. So in question 1 here, this one's a little bit different. So we're going to see different types of problems. So we've got x cubed, and the area where we've got x cubed is between the y-axis. We want to find is the y-axis, and the line y is equal to 8. So the first point we got here, we want to integrate. When we integrate, we get the area below the x-axis. So when we're going to do that, because we'll show you what we need to do, we firstly need this point B though. So we know that when we've got that point B there, that the y value is 8, because along the line y is equal to 8. So the x value, when y is equal to 8, x would have to be equal to 2, because the cube root of 8 is 2. So we can see that's where it's going to exist. So if we find the area here for under the curve x cubed from 0 to 2, again integrate, substitute our values, it's going to give us 4, so the area here is 4. Now, what we want is the area in this part, so what we're going to want to consider is that this is going to be a nice little rectangle as well. It's not drawn very nicely, but it's a rectangle. 2 there, 8 there. So if we take the area of our rectangle and subtract the area under the curve, that's going to leave just what's above the curve, and that's going to be our required area. So that's why we've done the 2 by 8 minus the 4 gives us 12. So that's our area that we require just by doing a little bit of subtraction there. The next one here is one where, again, we draw it up. We want the area between the curve y is equal to x squared minus 1, so there's our parabola, and the lines x is equal to 0, which is the y-axis, and x is equal to 2. So our area is in here. So there's the area we want, and there's the area we want there. Now, on my diagram, I can see that this area here is going to give me something that's going to be negative. So if I'm going to go 0 to 1, I'm going to take an absolute value around that part of the area. And I'm going from 1 to 2, that's just going to be positive, so that's not a problem. So I do the integration, x cubed on 3 minus x, 1 and 0 my limit, so I put the 1 in, I put 0 in. That's going to give me minus 2/3, which I'm going to take the absolute value on, so it's going to be positive. X cubed over 3 minus x, again, we've got do the substitution with 1 and 2. We put that in, that's going to give me a positive answer because we know it'd be working out positive. All up, it's going to give me an area of 2 units squared. So we've just got to be careful when where we've got a negative part. And if we draw it up every time, it shouldn't be too hard. Find the area this time between x squared minus 2x minus 3 and the x-axis. So if we draw that up, we need to say, well, we're going to get a factorization. So this is part of the problem that we need to be able to do, and we're going to see, well, it's going to give us a plus 1 and a minus 3, which means that it's going to go through 1, minus 1 and positive 3. Now, if we want to find the area between the curve and that, there's our area, curve to the x-axis. Okay, well, notice the whole thing now is below the x-axis. So if we did our integration, we'd actually come out with minus 10 and 2/3. Now, I've seen a lot of students get to that point and go, ooh, oops, negative answer, put my absolute values there. Okay, well, technically we take that because you're gonna, as long as you realise that you can't have a negative area, but realise that we've got an area at the end that is negative, we must make it positive. We're not really going to worry about it. What really is a worry with those sorts of students and solving problems that way is that have they considered the area maybe below and above the curve being positive and negative. So that's the problem when you see students do it that way. So you just got to be careful to draw it up correctly. Again, we don't have to have great diagrams. I'm doing well because I've got a nice little program to do it for me. But we've got to be able to get our parameters and work out all the bits of the problem, such as finding where it goes through the x-axis so we know our limits of integration, and being able to see where it is above and below the x-axis. So a nice little diagram will generally help us do that.